Hi students, I am Meenakshi, working as Assistant Professor in Rohini College of Engineering and Technology. So we are going to see the course Network Security and the topic is PGP. The main objectives are to learn about the basics behind PGP and to learn about the functionalities of PGP. So we all know that email is the most widely used network service. But currently, the email contents are not secure because it can be captured during the transmission time or otherwise it can be read by the authorized person. So to provide email security, we are using the service Pretty Good Privacy PGP. So it is widely used to secure email application. It is developed by Phil Zimmerman. He selected all the available best cryptographic algorithm to provide this service, and this PGP can be integrated into a simple program. It can be integrated into a single program, and we can run PGP in various operating systems like Unix, Macintosh, and so on. And initially, PGP is a free one, but nowadays we have commercial versions also. So we move on to the functionalities of PGP. So the functionalities are authentication, confidentiality and authentication, compression, and the email compatibility. So what is authentication? So here the sender creates the message, and by using the SHA hash function, 160-bit hash code is generated, and this 160-bit hash code is encrypted using RSA algorithm. For encryption, we are using a sender's private key. After the encryption, it is concatenated with the original message and it is compressed. It is given to the receiver. At the receiver end, initially the message is decompressed, and from the decompressed message, we have again calculated the hash code, and the calculated hash code is compared with the decrypted hash code. So if both are equal, then authentication is okay. So that is the sender, the sender creates a message. From that, the hash code is generated. The hash code is encrypted, and the original message and the hash code is appended. It is compressed and it is transmitted. At the receiver end, the message is decompressed, and from the original message, we are again calculating the hash code. The encrypted hash code is decrypted. So the calculated hash code and the decrypted hash code both are compared. If both are equal, then authentication is okay. So we move on to confidentiality. So the message is created and the sender created 128-bit random session key, that is this one. By using the session key, we are encrypting the message. Before that, if we want, we can apply the compression process. Then the message is encrypted. The encrypted message is appended with encrypted key. So to encrypt the key, we are using RSA algorithm, and for that, receiver's public key is used. Then all are transmitted to the receiver end. At the receiver end, initially, the key is decrypted. To decrypt, we need the receiver's private key. Once the session key is decrypted, It is used to decrypt the encrypted message. So we got the decrypted message here. After that, it is decompressed. Then the original message is recovered. So this is confidentiality. So then we move on to confidentiality and authentication. That is, it can provide both the services on the same message. So we have to create the signature, and the signature is attached to the message. So we are encrypting both the message as well as the signature. So that is, the hash code is encrypted. Similarly, the message is encrypted. So we are using RSA or Elgamal algorithm to encrypt the session key. The next service is compression. So PGP usually compresses the message after signing but before encryption. So this is the usual process. That is, before encryption, you have to compress the message. And it can happen after signing. So this is the order. So why we are doing like this means, then only we can store the uncompressed message and the signature, and we can use them for later verification. For compression, we are using zip algorithm. So then we move on to the next functionality, email compatibility. So we all know email can support only text. PGP must encode the binary data into the ASCII characters. For this conversion, we are using Radix 64 algorithm. So it converts the binary data to ASCII data. And if we want, we can append CRC for error checking. If the segment is very long, then you can fragment them into a small pieces. So this is the overall summary of PGP. So we have the content. So if we want the signature, then you have to create the signature using the hash function. After signing, you are applying the compression. Then if we want confidentiality, then you have to encrypt the message as well as you have to encrypt the session key. Both the messages as well as the session key is encrypted. Then we are converting into ASCII characters. At the receiver end, so initially we are applying Radix 64 conversion. So then we are recovering the session key and we are recovering our original message. So if the signature is there, then we are comparing the signature for further verification. So that's about PGP overall functioning. With this, I am concluding the topic. Thank you all.